Hello students, welcome to EDUHUNT online video classes. In the previous session, we have discussed a few questions. In this session, we are going to see a new concept that is called area of a rectangle and area of the path. Okay, right, let's see. Area of a rectangle and square paths. Before going to this area of paths, first we should know the area of rectangle and area of the square. Let's see. It's a rectangle. This is called length. This is called breadth. So, area of a rectangle is area is equal to length into breadth. This is the area of a rectangle. If I take a square, it's a square. In square, all sides are equal. This is A, this is also A. Area equivalent to A into A. Again, length into breadth. Here, length and breadth both are same. So, that's why A into A, that becomes A square. So, area of a square is A square. Okay. This is the area of a rectangle and the area of the square. Now, let's see the area of a path. This is a rectangle. This is a small rectangle which is having length L and breadth B. So, another rectangle is surrounded by this rectangle. This length is W. This is called width. This length is also W width. Both are same. This is also W. This is also W. This is W and this is W. Now here we have to find the area of the path. How do we find? See, here if we clearly observe, this is one rectangle. In this rectangle, another rectangle is there. This is another rectangle. This is a small rectangle. Now, what we have to find? Area of the path. What is path here? Let's see. This is the path. This is the path. This path area we have to find. How do we find? It's very simple. It's very simple. First we have to find the area of this outer rectangle and find the area of inner rectangle. Now subtract both the areas, then you will get the area. First we have to find the area of inner rectangle. Area of inner rectangle equal to L into B. Inner rectangle is L into B. Now, we have to find the length of this outer rectangle and breadth of this outer rectangle. So, length of outer rectangle, so let's take outer rectangle. Length is equal to, this is inner rectangle, this is W, this is W. So, L plus 2W here. Breadth is equal to, this is breadth B, this is W, this is also W. So, B plus W, it becomes 2W. Okay friends, right. See here, L is equal to L plus 2W, B equal to B plus 2W here. Now, find the area of this outer rectangle. Area equal to length into breadth, that is L plus 2W into B plus 2W. Now, multiply this one. This becomes L into B, LB plus 2LW plus 2BW plus 2 2's 4, 4W square. This is the area of outer rectangle. Now what we have to do? If I want this area, I have to subtract this smaller rectangle from the outer rectangle. Now area of the path, equivalent to this area. This area is, I am writing over here, LB plus 2LW plus 2BW plus 4W square minus LB. This LB and this LB cancelled. So the area is 2LW plus 2BW plus 4W square is the area of the path. This is how we have to find the area of a path of a rectangle which is having width W. Okay, let's see the next one. If the rectangular path of uniform width W units lies inside a rectangular dimensions L units and B units. See here, in the previous question, we have taken L and B inside. Now, see here, this is L, this is B. One rectangle is there that is inside this rectangle. So, width is W here. So, now find the path area of the path of this rectangle. This path area I have to find. This path area I have to find. This is W. Okay. Now, outer rectangle. Area is equal to L into B. Inner rectangle. Length is equal to L minus 2W. Why L minus 2W? This is W and this is W. 2 W's I have to subtract from this whole length. And breadth is equal to B minus 2W. How? This is breadth. Okay. So breadth, from breadth I have to subtract 2 widths, that is wide W. Okay. So now I have to find the area of this inner rectangle. Area is equal to L into B. So L minus 2W into B minus 2W. Now multiply these two. L into B, LB minus 2LW, multiply this minus 2BW minus into minus plus 4W square. Now subtract this inner rectangle area from outer rectangle area, then only we get area of the path. Outer rectangle area is LB, path area minus LB minus 2LW minus 2BW plus 4W square. Now multiply by minus all terms. LB minus LB plus 2LW plus 2BW minus 4W square. So this LB and this LB will be cancelled. So area of the path is 2LW plus 2BW minus 4W square is the area of the path in this case. Okay, right. This is the diagram which is related to this one. Next, let's see the path area of a square. What is a square area? Side into side are A into A, that is A square. This is the area of a square. This is inner square and this is outer square, which is having S units. Inner square and outer square. This is S units. This is W. So this becomes S plus 2W. This also becomes S plus 2W because all sides are equal in a square. So find the area of the path. This is the path area I have to find. This path area we have to find. So area of the path is equal to area of path, directly we can write, is equal to area of outer square minus area of inner square. Right. Area of outer square minus area of inner square. Area of outer square length is s plus 2w whole square minus s square. S square plus 2w whole square means 4w square plus 2 into s into 2w minus s square. This s square and s square will be cancelled. Answer is 4w square plus 2 2's 4 sw. This is the area of a path of a square in this case. Okay. Let's see if the square is having s units of side and inside this another square is there which is having width w. Now area of the path means this we have to find. So area of the path is equal to outer square area minus inner square area. Okay, outer square area is outer square measurement of square is s, so s square minus inner square area, so s minus 2w whole square. S square into, expand this one, s square plus 4w square minus 2 2's 4 4sw. Now multiply by minus s square minus s square minus 4w square plus 4sw. S square and s square will be cancelled. So it is 4sw minus 4w square. This is the area of a path of square in this condition. Okay, right. So in this session we have, now let's see the area of crossroads. If two crossroads are there in between one rectangle which is having width w. So this is a rectangle. In this rectangle, these two crossroads are there crossing like this. Okay, right. If we clearly observe this box, that means it is square. So this square is crossed two times. Okay, so that's why we have to find the area of this rectangle and area of this rectangle. We add both these areas of rectangles and again we have to subtract this one time. Why? Because it is calculated two times. For example, see, let me explain very clearly. This is path. Okay, right. This is another path. This is another path. That means here it is crossing two times. Okay, so that is why I have to subtract one box here. So that is, it is forming a square. That square area I have to subtract. Okay, so let's find the area of this crossroads. So first of all, we have to find the area of this rectangle. Area of that rectangle is area of rectangle HEFZ, HEFZ, L into B. That L into B equivalent to L is L, B is W only. Okay, and area of rectangle, this rectangle we have to find now. PSRQ, PSRQ is equal to L into B. So here L is breadth, B it is W, BW. So we have to add these two areas to find the area of crossroads. So area of crossroads is equal to LW plus BW minus this square area I have to subtract. That square area is W square. So minus W square, this is the area of the path here. This is the area of the two paths crossing over here. Okay, right. So let's find this question based on the concept which we have discussed in this session only. Find the area of the pathway shown in the following figure. This is 50 meters, this is 25 meters, and this width is 2 meters. What is the area of this crossroads? Area of crossroads is equal to the formula. This is L into W, this is B into W. So LW plus BW minus W square. So LW, L is length 50 into W is 2 plus BW 25 into 2 minus 2 square. Now 50 into 2 100 plus 25 into 2 50 minus 2 square is 4. This is 150 minus 4. 150 minus 4 is 146 meter square is the area of these crossroads or pathways. Okay, right. Let's see the next question. A sari 4 meter long and 1.2 meters wide has a border of width 25 centimeters all around it on the inside. Find the cost of knitting the border at 20 pies per centimeter square. 400 meters long, that means 4 meters long, that means 400 centimeters, and 1.25 meters, that means 125 centimeters. Why it is converted into centimeters? Because the question is asked in centimeters, that is per centimeter square it is costing 20 pies. So that's why its units are converted into centimeters. Okay, right. This is 350 and 75. So the border we have to find for knitting this one. Okay, so outer rectangle area minus inner rectangle area, then we get the area of this path. Okay, right. Area of outer rectangle (125 into 400). Area is equal to L into B, that is 125 into 400. 125 into 4. So 400, 25 into 400, that is 500, 2 zeros, centimeter square. And inner rectangle area equal to L into B equal to 350 into 75. Now multiply 5 5s 25, 5 3s 17 again, 24. This is 5, 12, this is 6, 2, 0 here, this 0. Okay, 6250, sorry, 2650. 2650 centimeter square. Now area of the path is, subtract these two values. Area of path or border is equal to 50,000 minus 26,250. So in 50,000, if I take 26,000, that there will be 24,000. In 24,250, remove 23,750. 23,750 centimeter square. So it's costing 20 pies per centimeter square. So I have to multiply by 20. So cost is equal to 23,750 into 20. So now 2 sevens, 2 5s 10, 2 7s 14, 15, 2 3s 6, 7, 2 2s 4, 0, 0. So I have to convert this into rupees. So cancel by 2 zeros because 1 pies is equal, 1 rupee is equal to 100 pies. So 4750 is the answer for this question. Okay, right. In this session, we have discussed area of the path and crossroads. Okay, in the next session, we are going to solve questions based on this concept. Thank you for watching.